What if there's a place in the universe where reality itself shatters, where time stops, space warps, and the laws of physics collapse? And what if that place could be a portal to another world, another time, or even another dimension? Hold on tight, because we're plunging into the darkest mystery of the cosmos. What are black holes really, and could they be portals? Hey there, cosmic adventurers. Welcome back to the channel where we unravel the wildest secrets of the universe, one mind-bending question at a time. If you're new here, hit that subscribe button and join our journey through the stars. Today, we're diving into black holes, those enigmatic objects that twist space, slow time, and might just be doorways to the unknown. They're not just cosmic vacuum cleaners. They're portals to a reality we're only beginning to grasp. So, let's jump in and explore what black holes really are, and if they could take us somewhere beyond our wildest imagination. Let's start with the basics. What is a black hole? It begins with a massive star. Think 10 to 20 times the size of our sun, reaching the end of its life. When a star like that burns through its nuclear fuel, it can't fight gravity anymore. It collapses under its own weight, shrinking down to a single point of infinite density called a singularity. This isn't just a small. It's a place where all the star's mass is crushed into a space smaller than an atom, creating conditions so extreme that our understanding of physics breaks down. Surrounding this singularity is the event horizon, the boundary where gravity is so strong that nothing, not even light, can escape. That's why black holes are black. They're invisible to our eyes, hiding secrets we can only guess at. But black holes aren't just about destruction. They're about gravity gone wild. Thanks to Einstein's theory of general relativity, we know that massive objects warp space and time. Picture space as a stretchy sheet. A star like our sun makes a gentle dip, but a black hole punches a hole through it, creating a bottomless well. Near a black hole, this warping is so intense that it affects time itself. If you watch someone fall toward the event horizon, don't try this at home. They'd seem to slow down, almost freezing as they neared it from your perspective. But for them, time would feel normal until they hit the spaghettification zone. That's where the black hole's tidal forces, gravity pulling harder on your feet than your head, stretch you out like a piece of spaghetti. You'd be torn apart long before reaching the singularity, making it a one-way trip with a gruesome end. Inside the singularity, things get even stranger. The density is infinite and the curvature of space-time is so extreme that our equations, like Einstein's, stop working. Some physicists think this could be a gateway to something new, while others believe it's a dead end where reality simply ceases. This mystery fuels the idea that black holes might be more than just cosmic graveyards. And that brings us to the exciting part. Could they be portals? To explore this, we need to look at a special type of black hole, one that spins. Most black holes spin because the stars they come from were rotating. These are called Kerr black holes, named after mathematician Roy Kerr, who in 1963 proposed a groundbreaking idea. A Kerr black hole has a ring singularity, a spinning ring of infinite density surrounded by a region called the ergosphere where space-time gets dragged along with the black hole's rotation like a cosmic whirlpool. Kerr's math suggested that the spinning motion could create a pathway through the singularity, a wormhole. Imagine falling in. If you somehow survive the tidal forces, and that's a huge if, you might pass through and emerge somewhere else. Maybe a distant part of our universe thousands of light years away. Or perhaps a whole new universe with different laws, different stars, or even different dimensions. Some theories even hint at time travel, with space-time so warped you could loop back to the past. It's a mind-blowing possibility, but wormholes remain theoretical. We don't know if they're stable, and surviving the journey is a long shot. Spaghettification and extreme conditions make it a deadly ride. But black holes aren't just ideas, they're out there and we're finding them everywhere. The first confirmed black hole, Cygnus X1, was spotted in the 1970s. It's about 15 times the mass of our sun and sits 6,000 light-years away, pulling in matter that glows in X-rays. Then there are supermassive black holes, like Sagittarius A** at the Milky Way center, 4 million times our sun's mass. In 2019, the Event Horizon Telescope gave us the first image of its shadow, a dark silhouette against a fiery accretion disk. These giants live at the hearts of most galaxies, shaping their structure and growth. And don't forget primordial black holes, tiny ones that might have formed right after the Big Bang. Some scientists think they could be linked to dark matter, adding another layer to their mystery. How do we study these invisible giants? We look at their effects. When a black hole sucks in matter, it forms an accretion disk, a swirling ring of gas that heats up and glows in X-rays, detectable by telescopes like NASA's Chandra X-ray Observatory. Black holes also bend light from stars behind them, a phenomenon called gravitational lensing, creating beautiful arcs in the sky that we've captured with the Hubble Space Telescope. And when black holes collide, they send out ripples in spacetime called gravitational waves. In 2015, the LIGO Observatory detected these waves, proving Einstein's predictions and opening a new window into the cosmos. Every observation is a CLUE to unlocking their secrets. Now, back to the portal question. If black holes are doorways, where might they lead? One theory points to white holes, the reverse of black holes, where matter and light pour out. A white hole could be the exit of a wormhole, spitting you into another reality. Another idea, called black hole cosmology, suggests the singularity inside a black hole might trigger a new Big Bang, birthing a fresh universe. If true, our own universe might have been born inside a black hole in another cosmos, a thought that turns reality upside down. These ideas are speculative, but they show how black holes challenge our understanding of existence. Let's take a moment to reflect. Black holes are more than cosmic monsters. They're windows into the universe's deepest mysteries. They stretch our minds, forcing us to question space, time, and what lies beyond. They remind us how small we are, yet how curious we can be. Whether they're portals to new worlds or just the end of a star's journey, they hold secrets that inspire us to keep exploring. And here's a final twist to keep you thinking. What if we could use black holes one day? Not to travel through them, survival odds are slim, but to unlock cosmic knowledge. Scientists dream of using gravitational waves to study the Big Bang or harnessing black hole energy for future tech. Some even hope they'll help us crack a theory of everything, uniting gravity and quantum mechanics, a goal Einstein chased but never reached. Black holes might be the key to our next big leap. That's the cosmic journey we're on today. What do you think black holes are? Portals to the unknown or cosmic dead ends? Drop your thoughts in the comments. I can't wait to hear. If this mind-bending dive into black holes thrilled you, give this video a like, hit subscribe, and tap the bell for more cosmic adventures. Share with a friend who loves big questions, and let's explore the universe together. Stay curious, stay engaged, and I'll see you in the next one.